everybody, and welcome back to another Miss Pollard YouTube video. Today we're going to be going over exponent rules and more specifically the product and power rule. And when I go over exponents, I really like to say that this topic rules. Let's stop with the corny jokes and let's get into the math. So something that we should know about the product rule is what do we do when we're using the product rule? So when we're using the product rule, we have to remember that we have to multiply our coefficients and add our exponents. This is one of the most important parts, is memorizing what do we do for each type. So this is very similar to our scientific notation multiplication and division, where we multiply the factors and then added the exponents. Same thing for our product rule. We're going to multiply and add, do that little dance move I taught you guys. The key point though here is that we can only add the exponents with the like base. So it's almost like when we combine like terms, you can only combine the ones that are of like bases. So if we're seeing two different exponents, we can't combine them if they have their different bases. So we have to be careful to underline or denote which ones are the same to be able to combine them properly. Let's take a look at one of our more straightforward examples so you can see exactly what we have to do. So for example, we have 8k to the fourth times 3k. Our explanation up here tells me to multiply the coefficients. The coefficients are the numbers in front of the variables. So I have my 8 and my 3. So I'm going to do 8 times 3, which is 24. So I have 24 there. Then I have to add my exponents, but only the ones of the like bases. So I have k and k, so they have the same base. We're good to go. We have to remember that this k is not just saying that it has an exponent of 0. If there's a k there, it has to have an exponent. We have to remember that that is going to have an exponent of 1. It has that little imaginary or invisible 1. And so we are going to use that to add our exponents. We have 4 plus 1 gives me k to the 5th power. So that was one of our more straightforward problems here. Let's take a look where we step it up a notch, and all we're doing is still applying it, just having more variables and more terms. Now we have this problem, and we're going to do exactly what we did before, where we're going to underline or figure out which ones are our coefficients. So I have a coefficient here of 6 and 8, and then we look here. What does this -1 mean for me? That -1 is not telling me that my exponent's negative. It's saying it has a negative coefficient. Well, just like we saw before, we have those invisible or imaginary ones here. It has that 1 here. So I would draw that in so I remember this is saying the coefficient is -1. And then times a 1 here, which we know anything times 1 is just going to be itself. So I'm going to do 6 times 8, which is 48. Times this -1 gives me -48 as my coefficient. Then I'm going to box off my variables to be able to combine their exponents, add their exponents together the like ones. So I have m to the 6th, I have another m, and another m. So I have 6 plus 4, which is 10, plus that 3, and that term gives me 13. So m to the 13th power. Now I'm going to do the same process with my n's. So I have n to the 8th, n to the 3rd, and this n. And remember that n has an exponent of 1. So I'm going to add those up. 8 plus 3 gives me 11, plus 1 gives me 12. So I'll have n to the 12th power. A lot of my students ask me a very great question. Does it matter the order in which I put the variables? No, it does not matter. I could put -48, n to the 12th, m to the 13th. The only thing that matters is that the coefficient is in front. So you can't have the coefficient behind or in the middle. It just looks a little weird. So to be mathematically correct, put the coefficient in the front, and the variables could go in any order. Now let's take a look at the power rule and see what we would do for those type of problems. For the power rule, we are going to do something a little bit different, where we are now going to raise our coefficient to the power given and then multiply the exponent. So this is something we have to remember. And the terms raise the coefficient to a power are really interesting. You might not understand that. So let's take a look at one of more straightforward questions to be able to see what am I talking about. So I have 6x to the 4th to the 3rd power. And I like to say if we can't remember what we have to do, break this up. So this is saying 6 to the third times x to the fourth all to the third power here. So 6 to the third, that means we are going to put in our calculators 6 times 6 times 6, which gives me 216. Then it's telling us to multiply the exponents. So I have 4 times 3, which gives me x to the 12. So when I say raise the coefficient to the power, it's telling us how many times to multiply that coefficient by itself. So for 6, we did 6 times 6 times 6 because it said 3 times. And then we multiplied the exponents. Let's step it up a notch, but we're doing the same exact process. All we're doing is adding a little bit more variables. Looking at this problem, it might look a little scary at first, but we're just computing the same things we were doing before. So I'm going to do 3 to the fourth power. And then if you need to, you can separate it. If you remember that I'm just multiplying these numbers together, you can do that. But if you need to break it up, we can do that. So I'll have y squared to the fourth power, x to the fifth to the fourth power, and the last one, z to the seventh to the fourth power. So just like we did before, we are going to raise 3 4 times. So 3 times 3 times 3 times 3 gives me 81. Then we multiply. 2 times 4 gives me 8, so y to the 8th. 5 times 4 gives me 20. And 7 times 4 gives me 28. So like I said before, it's the same exact process. All we're doing is adding more variables. So if we can do it with one variable, we can do it with the whole alphabet if we wanted to. I know you don't want to do it with the whole alphabet, but you could. So that's impressive. Let's take a look where I'm now going to combine the rules and see what we should do first. So for my combination, I'm going to give you a problem where it's having multiple terms being multiplied together inside parentheses raised to a power. So there are different ways that you can apply the power rule and the product rule together. I'm doing it in the sense where we have a long string of terms being multiplied together with parentheses and an exponent above. So in these steps, we have to think back to PEMDAS. PEMDAS tells us to do inside the parentheses first, then do the exponent. Of course, in these type of problems, you can do it the opposite way, but I think it makes most sense to stay with what we know. PEMDAS, it tells us to do inside the parentheses, so let's do that first. So inside the parentheses, we'd be working with the product rule first. So for these problems, I'm going to tell you to always use the product rule, then the power rule. So we're going to complete inside the parentheses first, do inside, which is the product rule, then use the power rule. So let's look at this example, which looks very scary. You're seeing all these variables, both terms. It looks wild, whoa, but I know we can do it. So we're going to use our product rule, which is we're just going to look at the inside. We're going to act like these parentheses and exponent are not there. So using the product rule, we multiply our coefficients, add our exponents. So 4 times 2 gives me 8. Then I'm going to do my y and my y squared. I'm going to add them because that's what the product rule tells me to do. So 2 plus 1 gives me 3. Z squared and x squared and x to the 4th give me x to the 6th. Then finally the z to the 5th and z to the 3rd give me z to the 8th power. All I did was add these exponents because they are the same like base. Now I can't forget though I have this squared on the outside, so I have to throw it back into the problem. So now I'm going to use the power rule like we just saw. So I'm going to do 8 squared, which is 8 times 8, which we know is 64. Y to the 3rd squared means we multiply. Now we're using power rule. 3 times 2 is 6. 6 times 2 is 12. 8 times 2 is 16. And this would be my final answer here. So like I said before, a lot of these problems look scary because there's so many variables, but once you're able to do it with one variable, you can do it with all of them. So I hope that this was helpful with the power and product rule, and thanks for watching.